Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. Finding a bug in production is never a fun experience, especially when your users find it first. Airbrake error monitoring ensures that you will always be the first to know, so you can deploy a fix before anyone is impacted. With open source agents for Python 2 and 3, it's easy to get started, and the automatic aggregations, contextual information, and deployment tracking ensure that you don't waste time pinpointing what went wrong. Go to podcastinit.com/airbrake today to sign up and get your first 30 days free and 50% off 3 months of the startup plan. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macey, and today I'm interviewing Mourad Mourafiq about Polyaxon, a platform for building, training, and monitoring large-scale deep learning applications. So Mourad, could you start by introducing yourself?
Yeah, sure. My name is Mourad. I'm the author of Polyaxon, and before starting working on Polyaxon, I worked couple of years in investment banking. Then I tried a couple of startup ideas, did not work, and I decided to go back to work. And I joined some tech companies, some startups. And recently, again, I left my job and I'm working full-time on Polyaxon. I don't know for how long, but yeah, for now I like it.
Taking a leap of faith.
Yeah.
And do you remember how you first got introduced to Python?
Yeah, I think the first time I was introduced to Python was back in 2010, I guess. It was through a colleague of mine. I was living in Luxembourg. At that time, I was doing a lot of C and C++, some MATLAB, some Excel also for the front office for an investment bank. And my colleague was telling me about his experience writing some text mining scripts to extract sentiment that could be beneficial for trading. So I also started playing with the language. I quite liked it, and especially the numerical libraries. I was automating a lot of reports and analysis in structured and organized way. And by the end of that year, I also started working on 2 projects. One was related to credit derivative pricing and rating, and the other one was a web app. So it was natural that I was using Python for both, and since then I was relying on Python for many of the things that I'm doing.
Yeah, it's always astonishing the breadth of things that you can do with Python and stay within the same language. And occasionally you may need to integrate with a compiled binary to get some performance improvements, but at the user level, it's all still just Python.
Yeah, exactly.
And can you start by giving a quick overview of what the Polyaxon project is and your motivation for creating it?
So I started working on it was not called Polyaxon at that time. It was just a couple of scripts that I put together when I started using Tensorflow in 2015. At that time, there was a small team at Google that was working on scikit-flow. It was something similar to scikit-learn, but for Tensorflow. I liked it, and then they moved it inside Tensorflow as a contrib-learn. And since then, it was breaking every time they were upgrading. So I thought that I would build my own small library. And I've been working on that since then. Eventually, it became Polyaxon because I started also thinking about persistent experiments, reproducing them, how we can also integrate learning in different kind of environment like Docker or Kubernetes. And last year in September, I thought that maybe I should just work full-time on Polyaxon and basically try to realize the vision that I have behind it.
And in the context here, when you're referring to running an experiment, is that for just doing quick iterations on a machine learning model to figure out how best to approach a problem?
So the thing is, when you are building a machine learning or a deep learning model, depending how big or complex the model is, there is a couple of things that you will be thinking about. Like, for example, you need first to write some code, and I assume that this code is version controlled. So basically, you are tracking the changes of your code, and then this code is basically responsible for doing many things. You have like the cleaning of the data augmentation, extracting and engineering features, doing some data exploration, some analysis, and then you start thinking about the core machine learning, the core deep learning model that you want to train. This model need to load this data and start training, and eventually exporting some outputs, logs, as well as other artifacts like model checkpoints, weights, and so on and so forth. So this process becomes more or less tedious each time. So a lot of people start thinking about abstracting this process into something that could be like where you can just like put some code and then it's running, it's doing all these kind of things without thinking about like I should do this first and then that's afterwards.
Polyaxon, you mentioned Kubernetes and Docker. So wondering if you can describe a bit about how it's implemented and what the internal architecture looks like.
So as I said, like a data scientist or a machine learning engineer basically writes code and try to train this code. Eventually the machine learning engineer also thinks about like restarting the experiment if she's not satisfied with the results. Eventually also potentially deciding to share the work with the rest of the team to compare the results with previous experiments. She might also like decide to retrain the model or basically just like to pass the work to one of the teammates. But the problem is in order to restart an experiment or retrain the model in the same fashion, in the same way, it becomes really difficult because you have to handle environment variables, dependencies, environment setup, and so many other things. So the container technology gives you this ability to basically package everything and have it basically reproducible. So that's what I'm doing with the Polyaxon. Basically, whenever machine learning or a data scientist tries to train a model or run an experiment, basically Polyaxon keeps tracks of all the kind of like dependencies that are needed for this zone. So basically, we track the version of the code. We have a version control system that is built in Polyaxon. We have a Docker registry that's basically gets all the dependencies in a very simple way and builds a Docker image, run the experiments in a Docker image, and basically whether you want to do like parallel experiments or distributed learning, we have also like a very simple interface that basically starts running on Kubernetes. Kubernetes is very interesting because it gives you the ability to basically redeploy the same structure, the same infrastructure on your computer or on a cloud platform or basically on bare metal. So basically you have this huge engine that abstracts all the orchestration of your containers, of your resources, and yeah, that's how basically the core of Polyaxon is working.
What is it about deep learning workloads that makes it necessary to have a dedicated tool for deploying them, particularly for being able to manage a scale-out environment to parallelize the experiments that you're running?
Yeah, I think deep learning and machine learning in general is maturing as we in the last couple of years, but it's not as mature as software engineering. There's a lot of technical depths that gets introduced every project. So depending on the organization and also like the processes that they have inside for their teams, you will see like different kind of like structures. But in general, it's not as rigorous as software engineering. So there's a lot of the dimensions that's basically. And a lot of technical debt that is related, for example, to data versioning, technical debt that is related to configuration, hyperparameters, to code, to resources, for example. Starting an experiment with all these kind of like dimensions is really hard. So basically, when you have someone building a deep learning or machine learning model or trying to solve a problem within a company, in general, you have all this kind of like configuration, and people like rely on documentation to reproduce the results. So if, for example, one of the engineers leaves the company or basically is sick and someone is trying to pick up the work, it's really hard to reproduce the same results. Or basically, if you want to, there's also like another problem, which is the staleness of the models. So basically you need to retrain the models every now and then. And it's a lot of knowledge that is not distributed equally, because basically people are relying on documentation, which is not always a good idea. So basically with Polyaxon, we are trying to bring some kind of like rigor and some kind of like organization to deep learning and machine learning in general, so that basically the data science team can focus on the algorithm and then just have a system that basically tracks all these kind of dependencies and gives them an environment that they would be able to reproduce the experiments and reach the same results again and again.
And a lot of times when data scientists are working through a problem and exploring the problem space, and then they generate a model, occasionally it's necessary for another engineer to take that model and then translate it to a different language or a different architecture, or just modify the way that it's implemented to increase efficiency for being able to deploy it in production. But if the model is already contained within a Docker container, have you found that it's possible to just take the output of the experiment that you're using with Polyaxon and then just push it straight to production?
No, that's one of the things that Polyaxon brings to the table. So basically, you don't care about like creating Docker images or anything. So you just write code, and basically you say that I want to run this code on Polyaxon, but in order to run this code, I need these dependencies. Anything that could run on Docker is basically something that we can use on Polyaxon. So basically, if you have a code and you change it to, like, for example, fine-tune some kind of parameters or change the structure of the code, you just like push the code and it's basically automatically version controlled in our system, and it creates a Docker image and starts the experiment. So basically what we are doing with Polyaxon is like we are abstracting more or less the data science workflow and simplifying it. But also we are allowing the data scientists to only focus and iterate on their algorithm without having to care about all these kind of like dependencies and specific things to the experiment. So that's, for example, you just have a configuration file, a small YAML file, and basically everything is handled by Polyaxon, like the configuration, tracking, the resource allocation, and also like basically you have an API, so you can do that also like programmatically if you don't want to use the command line interface. So also like Polyaxon allows like different ways of like scheduling the job, so that, for example, you can have also like experiments running through with some kind of like schedule for example every week or every 2 weeks, or for example if there's like some new data in a database, there's like triggers being built right as we speak. So that's basically you can train many models, optimize many kind of like experiments on a cluster by using the maximum resources, GPUs and everything.
So in a way, it sounds a lot like Polyaxon is aiming to be the continuous integration system for machine learning, because in a traditional continuous integration system for a pure software project, you would want to be able to have those periodic builds to ensure that everything's operating properly, and then also have the build on a code push. But because of the added complexity of requiring the data to be present for machine learning workflows, I imagine that adds some complexity to a standard continuous integration system.
Yeah, there's as I said, like there's like two kind of like phases, two kind of like dimensions. There's like the dashboard, which is basically just like for viewing and reviewing the experiments, so that you have some kind of like knowledge distribution within the team. So basically you are working on a project with the other team members, you are working on your own kind of like experiments, and you want to compare their experiments and then the values and how these experiments are like different. What makes these experiments better than the other one in terms of like hyperparameters and other kind of like configurations. And there's like this part of where you want to also like automate as much as possible. So there's like the core model of machine learning is very small compared to all the entropy around, like all the data management, configurations and everything. So what we're trying to do is basically use Kubernetes, which is really good for orchestration as a class of the cluster, for managing the resources, for reproducing the same deployments everywhere, and also for scaling. And with Polyaxon, we are adding a specific layer that is trying to provide some kind of like reproducible and scalable machine learning and deep learning on top of Kubernetes. So basically we have like authentication and user management for projects, for machine learning projects, and also like having some kind of like modular kind of like architecture where you can, for example, install only some parts of like the platform for doing a couple of things, for example, for the installing just the dashboard, or having also like the engine, the runner, or having also like the pipelines for doing, for example, the whole continuous integration of the machine learning, so that, for example, you can say, I want this experiment to run every Monday, or run basically whenever there's some triggers happening.
And when you're doing those periodic builds, is it possible to set some sort of expectation of the output to ensure that it's staying within certain bounds so that you can be alerted if something is not operating as intended, or whether there's new data that's causing the model to behave in an unpredictable fashion?
So basically, with the idea behind this pipeline is that it gives you more or less some kind of a higher like abstraction of doing whatever you want. For example, integration with the different kind of like environments. For example, Slack. So for example, you can say, if the last experiment has accuracy or like a loss of this value or that value, send me a notification, for example, or restart training based on a different kind of like time range or whatever. So basically with this kind of like pipelines, you can build different kind of like workflows, and yeah, you don't need to basically watch your computer, like have some kind, because right now what most people do is like they have some kind of like session somewhere on some kind of machine, they have to SSH and check what's happening. If the machine is gone, basically the logs and all the artifacts is gone. And that's what we're trying to do with the Polyaxon, is basically have all these kind of like components separated, so that you never lose like your logs, artifacts, outputs, and you have all this kind of like links between how the lineage basically of how this experiment started, why it reached this result, and how to reproduce it.
And going back to the step of building the Docker container to be deployed onto Kubernetes and run via Polyaxon, as somebody who is new to the overall technology of containerization, it can be difficult to figure out how best to approach encapsulating everything into one image and having a entry point that will function properly. And it sounds like you've attempted to abstract out all of those concerns of writing a Docker file, figuring out what needs to go into it, how it gets executed. But for somebody who it needs a bit more control, what are some of the tips or best practices that you found for creating containers that are going to be used to execute these deep learning or neural network type workloads?
I mean, so how Polyaxon works is very simple, basically. You always have to provide some kind of like base image. If you're running your code on, for example, Python 3, and you need to install TensorFlow, basically there's like a TensorFlow image. But imagine, for example, you want to install it on like a Python 3, for example, Docker image. You just provide the base image, and then you have like some build steps that you need to provide. For example, pip install TensorFlow, and then the command that you want to run on your code. So basically, you don't the process of creating a Docker file is very abstracted. That it seems very simple. So you don't need to provide many things. You just need to provide a couple of dependencies that you want to install on some kind of like machines. And going back to whether you have like more, whether you want to have more control over like the Docker images that are being built. Of course, you can create a very complex container. For example, you can upload it to some kind of Docker registry, and then you can reuse it within Polyaxon. So it's not mutually exclusive. How you can use like if you are like very proficient and you know what you want to do with the Docker image, of course you can do whatever you want, and then you can just like reuse it within Polyaxon. But Polyaxon just provides this very simple interface between the user and Docker, so that it's not forcing the researchers to be proficient DevOps people, so they can just run their experiment without like having to think too much about like how the specificities of how a container is running.
And in Polyaxon, you're supporting a number of different libraries for being able to execute these deep learning workloads. So I noticed that there are things like TensorFlow and Keras and scikit-learn. So I'm wondering if you can discuss some of the relative trade-offs or comparison between the available libraries or the available frameworks, and also maybe some of the complexities that are involved in being able to support all these different targets.
Yeah, so basically, since the platform is built and relying on Docker to start like the experiments, we can basically support any framework. In fact, you can run anything can run on Docker. That being said, for users who wish to run distributed training algorithms, that's when the complexity becomes really, when the complexity increases, is basically we provide very simple interface for distributing the work on a user-defined topology. For example, for running a simple TensorFlow model, you can run it basically with on your computer or on any platform. But for example, if you want to run a distributed training on TensorFlow, you need to build some kind of like topology, and this topology needs to communicate, like all these virtual machines need to communicate between them. Same thing for other frameworks. So what Polyaxon does is basically provide a very simple interface where you say, for example, I need this number of machines, and this is their role. For example, it should be a worker or parameter server or a master. And we build this topology, and basically you run your code within this topology, and Polyaxon knows how to make this virtual machines talk with each other and reach some kind of like results. So basically, what we provide a simple interface for TensorFlow as well as Horowod, but also for PyTorch and MXNet. There's some trade-off between these technologies. Some of them are well documented, and there's a lot of tutorials, for example, TensorFlow. And yeah, for others, it's really hard. And like for many people, they don't, you need to, for example, for MXNet, you need to rebuild Docker image with, and basically have some kind of like configuration enabled. Both TensorFlow and MXNet, they have more or less similar kind of like architecture in terms of you have a master and you have parameter servers and workers. For PyTorch, you have only like a master, which is you have a couple of workers, and the master is the worker with rank 0, and all the other workers are basically communicating with each other depending on how you want to do that. So basically, in your code, you will have to specify what kind of like architecture you want to build. Polyaxon only builds the topology and provide it for the user.
And for somebody who is getting started with Polyaxon, what's involved in setting up the integration with Kubernetes, assuming that they already have the Kubernetes deployment available?
Yeah, I mean, Polyaxon is using Helm charts. So Helm is the official package manager for Kubernetes. We provide like some charts. So basically, the user just need to basically install Helm, install our chart, and the platform will start working on the top of Kubernetes in some kind of like namespace that the user also creates. And yeah, from there you need also like our command line interface to basically talk with the API, and from there everything just works. In the next few versions, we will have also like we will separate the core runner, which requires Kubernetes, and the dashboard, which is basically just having an interface over what's project experiments, group of experiments, user management, so that you can, for example, install this dashboard on a Docker Swarm, and you don't need to use our runner. You can run the experiments on your own cluster in a different way, and basically just upload all the data like related to each experiment. For example, you just have some kind of like hooks that's you install within your code in your experiment, and they are just like sending metadata about like the experiment, so that you can have a dashboard without having to care if you want to run your experiments with the Polyaxon runner or with different kind of like engine.
So that would let somebody use, as you mentioned, Docker Swarm, or for instance, something like Mesos if they don't have Kubernetes and don't want to introduce that to their infrastructure.
Exactly. So for example, imagine you have Spark and you have using the Spark ML library, and you're running all your experiments within Spark, and you want, but you still want to track how these experiments are running, what kind of like configurations they're using, what kind of versions of code they're using. And yeah, so basically you just install the Polyaxon dashboard and you run your experiment on Spark, and basically you have all these kind of like APIs that's called Polyaxon API. To persist all the different configurations for each and every experiment, so that you have comparison and historical data over your machine learning process.
And if somebody has an existing workflow, an existing code base for a machine learning project, is there anything special that's involved in migrating to using Polyaxon?
Yeah, of course you need to have, for example, it depends obviously on what parts you want to install. For example, you want to have only the dashboard or also like the runner. But in general, at least in my experience, most of like machine learning and the data science team, they basically run experiments or on their computers, or if they have some kind of like a company cluster where they are just like SSHing to the machines and running the experiments. In that case, if you are using only the dashboard, you only need to have like our SDK installed in your code, and then basically running whenever you run an experiment, it basically extracts all the metadata and send it to the dashboard. If you want to use the full platform with the runner and everything, so basically you need to have the command line interface, and then you have the specification files, the YAML files, where you say how you want to run your experiments over Kubernetes. And basically from there, everything stays the same. You don't even have to change anything within your code, because everything is running within Polyaxon's platform. So it's tracked, and you can reproduce it whenever you want.
And as I was looking through the documentation, I noticed that there's a library implementation that you have as part of this project that looks as though it aims to abstract out a lot of the steps involved in just building a simple model so that it's easier for people to get started without having to dive into TensorFlow or PyTorch, etc. I'm just wondering if that's an accurate interpretation of the intention of that library, and if so, how somebody would go about getting started with that.
It's not very well maintained right now. So basically, it was the idea behind the Polyaxon library is to have describable models, so that you don't have to write even code for most of the machine learning or the deep learning architectures, the well-known architectures, so that you just specify some YAML configuration where you say, I want to use this model, and this is the architecture inside the engine, and then Polyaxon knows how to create the whole model and train it.
And you mentioned that it's not currently being well maintained, so that was just an experiment to see if it was viable, but the main body of the work that you're doing now is more on managing the orchestration and deployment of the models.
Yeah, exactly.
And what have been some of the most challenging aspects of building and improving Polyaxon, whether from a technical level or from just raising awareness and making it understandable to people who are interested in using it?
I think there's like two type of users for Polyaxon. So the data science teams in general, they know most of these problems, and if you work at any company where you have at least like a mid to big data science team, you will find like at least some people working on some kind of internal tool to abstract this machine learning and deep learning training kind of like workflow. On the other hand, you have also like the single developers. For these people, it's kind of like hard to convince them to use Polyaxon, because it's a big kind of like infrastructure for running only like experiments of one user. But for anyone who wants to have like reproducible models, for anyone who wants to have historical data about like their machine learning experiments, I think it's necessary to have something comparable to Polyaxon to at least track everything that is running.
And are there any particular features or improvements that you have planned for future releases of Polyaxon, or a particular direction that you're intending to take the project?
Yeah, as I mentioned, having separating the concerns between the dashboard and the Kubernetes runner is one of the things that I'm working on. Having also the pipelines running and all the integration with different kind of like the databases, external tools like, for example, GitLab and Slack and many other Trello and many other kind of like platforms, so that basically you can have this integration with different tools, also like triggering experiments and workflows. This is mostly like what I'm trying to do. Also for authentication, a lot of people ask about like LDAP and how, for example, they can integrate easily with their systems for big companies in general.
And if you were to start the whole project over again, do you think you would still use Python for building Polyaxon, or do you think that there's potentially a different language that would have made things simpler?
Actually, when I started working on Polyaxon, at least like this current version, I had like very small microservices talking, and I had some microservices in Go. I had like the streamer in Node.js, but then the complexity became became really like hard to maintain for a single developer. That's why I decided to just go with the Python, because it's more or less manageable for me to have this kind of complexity. In the future, yes, whenever there's like a microservice that I think needs to have where the performance is important, I think I will move it to Go, for example. But most of the other things, I think Python is a really good language for building a lot of things.
And one of the other things that I found interesting about the project is that you're effectively wrapping the Kubernetes API with the Polyaxon command line interface. And I'm wondering whether you faced any difficulties in terms of figuring out how that interaction should be structured, particularly given that you need to be able to reflect it internally to the Kubernetes API.
Not really. I have like one API that access into the Polyaxon platform. It's basically through the specification, and from there I have a couple of spawners that it's framework dependent, and I'm building everything on the top of the Kubernetes Python clients to basically just create the pods and everything. I know that a lot of other platforms, they create CRDs, they customize the basically deployment or something, but I think the API, the Kubernetes Python client is good enough that you can create many kind of like workflows and customizable workflows. So yeah, in general, it's like one single entry points from the specification to the Polyaxon API, and from there basically having different kind of customizable workflows for running different kind of like frameworks.
And are there any other topics that you think we should discuss before we start to close out the show, or anything that we didn't cover?
Yeah, I believe that machine learning in the next 2 years will keep maturing, and there will be a lot of platforms that are similar, more or less, or trying to solve at least some of these problems that I'm trying to solve. Reproducibility in machine learning. There's particularly, for example, the data management and data versioning problem. I think it's a very hard problem to solve. A lot of companies are also trying to basically abstract this huge area, this huge dimension of not only deep learning but also in software engineering. What you have, because you have multiple access to the data, how can you version it, especially with the space and everything. Hopefully in the future also, like Polyaxon will be able to have some kind of abstraction for data management and data versioning. But apart from that, I think Polyaxon or any other platform is really important if we want to bring some kind of like rigor to the deep learning and machine learning space.
All right. So for anybody who wants to get in touch with you and follow the work that you're up to with Polyaxon, I'll have you add your preferred contact information to the show note. And with that, I'll move us to the pick. And I know that we already spent a fair bit of time talking about Kubernetes, but I've been digging into it more recently. And so I'm going to pick Kubernetes as a platform because it really provides a great way of abstracting out a lot of the operational concerns of running software and creates a fairly robust contract between software engineers and machine learning engineers and the operations engineers who need to manage the underlying infrastructure. So I've been reading the O'Reilly book, Kubernetes Up and Running, and that's been helpful to try and understand the concerns of Kubernetes and what that contract is. And also Kelsey Hightower has been doing a great job of creating a lot of communications tools and creating a lot of resources for people who are getting into the space. And there's a great podcast that he was on recently on the Food Fight show where he was discussing that. So I'll add links to all those things in the show notes for anybody who wants to dig a bit deeper into Kubernetes. And
Cool.
so with that, I'll pass it to you, Mourad. Do you have any picks this week?
I'm rereading actually Schopenhauer recently, so I started reading again Schopenhauer. That's what I'm doing when I'm not working on Polyaxon or something related.
Well, I appreciate you taking the time today to join me and discuss the work that you're doing with Polyaxon. It's definitely a very interesting project, and I think that it's a move in the right direction of making machine learning more repeatable and easier to share around the business that you're working with. So thank you for that, and I hope you enjoy the rest of your day.
Thank you. Have a nice day.